This is Algebra 2, Chapter 12, Section 4, in which we will study the law of sines. So far, when we've worked with these trig functions in triangle situations, they've been right triangles. We can work with them in non-right triangles, we just can't use the ratio tricks anymore. We're actually going to have to just trust our calculators. One application of non-right triangles working with trig is to find the area of the triangle. Now, you're familiar with one area formula. Area is 1/2 the base times the height. We've been using that one since, probably about 3rd grade. Suppose we're not given the height. Well, we can work around that if we use one of these three other formulas. Either 1/2 BC sine A, or 1/2 AC sine B, or 1/2 AB sine C. Any of those formulas will get the job done. Okay? How do you know which one of the formulas to use? Well, it really depends on the information you're given. If they told me side B and C in angle A, then I'm going to pick this formula. I'm going to pick the one that has the information I need in it. Or that uses the information I have, I should say. So let's find the area of a triangle. And in this situation, they've given me angle A. They've given me side B and side C. So I'm going to use the formula that has that information in it. One 1/2 BC times sine of A. Plug in the information we have. I'm going to make sure my calculator is in degree mode when I do this. Again, if you need help switching back and forth, just ask. I'll be happy to show you. Now it's just punch this in. 1/2 times 18 times 22 times the sine of 31. And it gives me just under 102 square meters. Okay. Your decimal part here may vary a little bit. That's okay. You know, if you left sine of 31 all the decimal places on your calculator, you'll get a little bit different answer than if you rounded it off. But neighborhood rule is in full effect here. Now, another application of using trig ideas for non-right triangles is to solve a triangle. When they ask us to solve a triangle, what they're asking us to do is identify everything we don't already know. So we need to find all the missing sides and all the missing angles. And one good way to do that is using something called the law of sines. The law of sines says if we name things so that the side across from angle A is called little a, the side across from angle B is little b, and then across from angle C is little c, then the relationship between the sine of the angle and the side across from it is a nice constant ratio. Sine of A over little a is the same as sine of B over little b, which is the same as sine of C over little c. And I have a little note here, use any pair. It depends on the information you're given. If you're given things about A and C, then those would be the two you would use. You wouldn't use B because you don't have any information about it. And we'll do one of these to get you the flavor of it. The best way to really learn how to do these is to get in there and start doing them. So I'm going to let you do that pretty soon here. we have triangle PNQ, and since those are the three variables they gave me for the letters, or for the angles, I'm going to use the same letters for the sides across from it. Angle P is 42, angle Q is 65, and side N is 5. Okay. Our job now is to find the information we don't have. Angle N, side P, and side Q. Well, angle N should be easy to find. It's 180 minus the angles we know, which gives me 73 degrees. Now that I know that, I'm in business. To make law of sines work, you need to have an angle and the side across from it. Well, now that we know that's 73, we have an angle and the side across from it. We're in business. Now we can use law of sines. I'm going to try to find P first. So sine of 73 over its side, which is 5, equals sine of 42 over its side, which is P. Okay. I'm going to cross multiply, and while I'm at it, I'm going to punch in sine of 73 and sine of 42. Then I'm going to go 5 times this decimal and divide by the odd one over here that needs to go away. And we'll find out that P is basically 3.5. Okay. Now that we have that solved, we can go through the same process to get Q. Okay. Sine of 73 over its side equals sine of 65 over its side. Cross multiply, and while I'm at it, I'm going to get the values for the angles. Multiply by those and then divide by the 0.956 gives me a value for Q. Law of sines, we like it a lot because it's just straight ratio work. You've been solving ratios for, probably about as long as you can remember or close to it. If you had questions along the way, hopefully you wrote those down. Bring those in with you, and we'll see you in class.